Hello everyone! Today we are going to be talking about total stopping distance. You are driving to school one morning after a long night of studying. As you drive, you are trying to remember as many details as possible. You snap back to reality and see a school bus ahead in the school zone. You know you must stop before the school bus, as there will be children getting off the bus any moment and crossing the road. How much distance does the car travel while you process what is going on and start to brake? Will you be able to stop in time? Does the fact that you are tired and distracted affect your reaction time and total stopping distance? The last few lessons and activities have allowed you to investigate the relationship between speed and braking distance and the influence that road conditions and driver alertness have on braking distance. These calculations for braking distance do not take into account the reaction time of the driver. In order to give an accurate idea of the actual braking time, we must add the distance the vehicle travels while the driver reacts. So here are some examples. We're going to take, let's say a driver takes 4 seconds to react to an icy patch on the road before he or she uses the brake to bring the car to a stop. If the car is traveling at 55 kilometers per hour, we can calculate the distance the car will travel by using our understanding of speed. If the speed is calculated by dividing distance by time, then we can isolate the distance this way. Speed is equal to distance times time, so the distance is equal to speed times time. So here we are saying that V is equal to D over T. This is an equation we did earlier. And so we can rearrange, moving the T up and the T up, we can get V times T is equal to D. So if you take 4 seconds to realize that you need to brake and you are traveling at a certain speed, then you will have traveled a certain amount of distance, just simply by multiplying those things. Now we do need to use the same units, so we're going to have to convert our kilometers per hour into meters per second. Because we have a time period in seconds, we need to convert kilometers per hour to meters per second by dividing by 3.6. We also did this in a previous video by taking our kilometers per 1 hour, multiplying it by our 3,600 seconds, our 1 hour, I think first we multiplied it by 1,000 meters divided by 1 kilometer, and then we also multiplied it by 1 hour, which is made of 3,600 seconds. So this is the same effect as dividing by 3.6, and the result is a value of 15.3 meters per second. So now we put in our known values into our distance formula. Here's distance is equal to the speed, V, and the time, 4 seconds, and we determine that 61 meters have already passed in those 4 seconds it took you to look up. That's at 55 kilometers per hour, so that's below the speed limit in many areas. If it takes you a whole 4 seconds to look up from your phone, or to look up from a conversation, or to look up from your radio, or your stereo where you're changing a CD or changing a station, that 4 seconds just cost you 61 meters of braking distance. And that's before we applied the brakes. So if there was a person only 50 meters away, then there would not be sufficient time to stop the car and avoid hitting the person. 50 meters, that's pretty far. However, to accurately get a picture of the total stopping distance, we must also add the distance plus the distance necessary to brake. So the braking distance is calculated by the distance equals the frictional constant that we're using and the speed squared. So therefore, the total stopping distance will be equal to the reaction distance plus the braking distance squared. So let's just assume that we are on a dry road. We're going to be adding in that 0.06 as our coefficient. This is the same value we used in the earlier video. And we're going to use our speed in meters per second. So the total braking distance will be 0.06 times 15.3 squared, which gives us 14.04 meters. If we add these two distances together, 61 meters plus the 14.04 meters, we get a total distance of 75 meters, even on a bright sunny day, if you are distracted. And that's why distracted driving is so dangerous and why there are so many penalties for distracted driving, because your brakes are only going to be doing, your braking is actually the small part of that. So applying your brakes is actually going to be the short part of that distance. The real long part is whether you are distracted or whether you were focused on the road. If you're focused on the road and it takes you less than a second to react, then of course this distance is going to drop a lot. If you're watching the road, and if you're not watching the road, you're playing with your phone, whatever, distracted by children in the back seat, all of these things, and you're traveling at a good speed, then of course the distance is going to increase a lot. So let's do an example. So let's look at an example of total stopping distance. Say your car is traveling 50 kilometers per hour on dry pavement when a dog runs across the road 34 meters ahead. If the driver's reaction time is 1.5 seconds, will he be able to stop? Well, let's identify some values we need. We need the dry concrete. That's from our table. It's 0.06. We need the velocity converted into meters per second. So dividing by 3.6. 13.9, and then we need to look at the braking distance. So the braking distance is going to be the coefficient multiplied by the speed squared. That gives us 11.6 meters. And now we find the reaction time distance. So we're going to take speed times time. So let's I like to write these formulas out one more time. D brake is equal to kv squared. D reaction is equal to speed times time. And we get another 20 meters. So if we add those together, we get 32.5 meters, and we just barely saved the dog. So we get about 33 meters rounded. The dog just barely made it. All right, so we have some questions. Let's try one question. You can pause the video right now, and then I'll do this question, and you can check your answer. So I'll just pause for a second. Okay, so now that you're back, I'm going to do this question here. So I have a speed of 40 kilometers per hour under rainy conditions. Remember that was 0.10 was k in the rain. And there is a person on the road 30 meters away. Will you stop in time if you take 1.5 seconds to react? So the distance total is equal to the distance of reaction plus the distance of brake. And so let's do the distance of the reaction first. Oh, we need our speed to be in, we need that velocity to be in meters per second. So I'm going to multiply that by the 1,000 meters for 1 kilometer, multiply that by 1 hour, divided by 3,600 seconds. So my value will be, or you can just divide by 3.6, that's the same deal, 11.11 meters per second. I keep a couple of extra decimal places just in case. It'll help you, it'll make sure that you, at the end of the question, you can round. So the reaction distance is just simply V times T. So we're going to take the 11.11 meters per second, multiply that by the 1.5 seconds. So let's see what that gives us. We can multiply 1.5 seconds. So that gives us 16.6 meters. Okay, so far we are okay. We haven't hit them yet. but then we have to take in our braking distance, right? And the braking distance is kv squared. So we're looking at that 0.10 times v squared, which is 11.11 meters per second squared. So let's see what that happens there. 0.1 times 11.11.11 to the power of 2. We get a total distance here of 12.34. And now we need to combine those two numbers. So 16.6 meters plus 12.34 meters to give us 28.94, which is essentially 29 meters. So did we hit them? No, but just barely. And if there's any error in our calculation, then we are putting them at a very high risk here. I'm just going to move some things around so that I can kind of clean up my answers here. Okay. Just want this to look nice. Okay. So how much distance is needed? How much distance is needed? We need 29 meters. So yes, we stop in time. This is an important thing to do in any of these questions, is look and see if you actually answer the question. So the question up here was, will you stop in time? That's the question. So this is the answer to the top question. This is the answer to the second question, how much distance is needed. So those are our two answers. You're on a snowy road and you decide to travel at 30 kilometers per hour due to poor visibility. There is a stop sign at an intersection 20 meters away and it takes you 2 seconds to react once you see it. Will you stop in time? And this is another example where a visual obstruction could increase your reaction time because you can't see during that visual interruption, like low visibility. So will you stop in time? So let's do some conversions. We have our 30 kilometers per hour. And we're going to be doing that division by 3.6 or multiplying by 1,000 and dividing by 3,600. And so that gives us our first value. .33. Okay, I made that way too big, so I'm just going to shrink that down. And so that's 8.33 meters per second. And we are doing it in snowy conditions, so K is going to be 0.15. And so now, will we stop in time? So how much distance is needed? We need to do the distance of the reaction, which is V times T. It says it took us 2 seconds, and we are traveling at this 8.33 meters per second times the 2 seconds to look. And so that gives us 16.66 meters. And then we're going to do the D of brake, which is our V squared one, KV squared, 0.15 times 8.33 squared. And let's see what that is. 0.15 times 8.33 to the power of 2. And we get 10.408 and meters. And so now we add those two together. So 16.66 plus 10.408 meters gives us 27.068 meters, which is essentially 27 meters. So will we stop in time? No. No, we will not. So we needed 27 meters, and we had only 20 meters to stop. So I think that's a really interesting question, right? Because we're traveling 30 kilometers per hour. That's a very slow travel speed. So the hope here is that your reaction time is going to be faster than 2 seconds. That's what I would that would be my solution to this problem is hopefully you're going to be stopping. You can't fix the road conditions. All you can do is fix how aware you are of the road. This is why it's really important that when we go out for travel, that we travel with ourselves awake and not distracted. All right, with that, we are done physics, so please expect a follow-up check-in, and then it's very soon after we will have our final physics assignment going out, and then we'll be on to our next unit. Have yourselves a great day.